All right, in this written problem, what we're supposed to do is sketch this transformed version of the cosecant function. But because cosecant and sine are reciprocals, it'll be a lot easier to sketch this function if we already have a sketch of this function. And as I mentioned here, sketching this function was the work that we did last week, so you might already start out with this. I think for the sake of this video, I'm going to quickly sketch this one and then spend a little bit more time using that to sketch this guy. So to sketch this transformed sine function, I think the easiest way to start out is to recognize that a, b, c, and d are -2, 1/2, pi over 4, and 1 respectively. And with those values, we can come up with the amplitude, the midline, the period, and the phase shift. The amplitude is always the absolute value of a, so because a in this case is -2, it's the absolute value of -2, aka 2. The midline is always given by the equation y equals d, so in this case d is equal to 1, so our midline is y equals 1. Period is always 2 pi over the absolute value of b, although b will always be positive in our class, so you can just write 2 pi over b. b is 1/2, so it's 2 pi divided by 1/2, which is equal to 4 pi. And the phase shift is -c divided by b. c is pi over 4, so I have negative pi over 4 divided by b, which is equal to 1/2. And if you divide these two fractions, you get negative pi over 2. What I typically do now is I incorporate these facts into the graph. We can start with our midline at y equals 1, shown in red here. And then because the amplitude is equal to 2, the maximum and the minimum of this transformed sine graph will be 2 units above and below this midline respectively. We now have our guidelines in the vertical direction, so we want to worry about the horizontal direction. We'll start with the phase shift, which tells us that at negative pi over 2, we could start one revolution of our graph, and then the period is 4 pi, so what that means is to complete one full revolution, I'll need to travel a distance of 4 pi in the horizontal direction. Because we're transforming the sine graph, we want to start out on the midline. So I'll locate negative pi over 2 on my midline. If here's negative pi over 2, here's the midline. What I'm saying is this point right here is going to be on my graph. And then I want to do one full revolution at a distance of 4 pi. So 4 pi from negative pi over 2 would be 3.5 pi. What I'm saying is I want to finish one full revolution at this point. The sine graph is also back on its midline halfway in between these 2 points. So I can put another dot here at 3 pi over 2. And then my normal orientation is for my sine graph to go up and then back down and then back up. However, if you look at your value of a, if it's negative, that flips your orientation. So because I have a -2 here, what that means is I want a minimum, not a maximum, halfway in between these 2 points. So I'll put a dot down here at the minimum, and halfway in between these 2 points, I want a maximum. I have my 5 points, which will allow me to draw one full revolution of this graph. And that's probably good enough, but for the sake of the solutions, I want to continue drawing this in both directions just to show the student a little bit more about what's going on. So what I'm going to do is I'm going to recognize that if I traveled another 2 pi to the left from here, so over here, I'd be back at my midline, and halfway in between these 2 points, I should be up here at another maximum. So this is a little bit more complete of a version of my transformed sine graph. From this graph, I can come up with the graph of the transformed cosecant graph that's shown here. Because I have the same values of a, b, c, and d up here as I do down here, it's this graph in red that I'm going to base my graph of cosecant off of. And I think that the easiest way to do that is to start with your vertical asymptotes. So what you need to know about cosecant is you're going to have vertical asymptotes anywhere your graph of sine is on its midline. So at these 4 different dots here where my graph is on my midline, you're kind of thinking about those are sort of like the zeros of the graph, even though this graph has been shifted so they no longer have a height of 0. And since the cosecant is the reciprocal of this graph, these points kind of act like points where you'll be dividing by 0. And since dividing by 0 is undefined, you end up with vertical asymptotes at those points. The next thing to recognize is because the reciprocal of 1 is 1 and the reciprocal of -1 is -1, the points that act as maxima on this transformed sine graph are going to be minima on the cosecant graph, and the points that act as minima on my transformed sine graph will be local maxima for my cosecant graph. What I'm saying is I'm going to have a point right here and here on my graph of cosecant, as well as points here, here, and over here. Now I'm just about done. All I have to do is sort of incorporate the dots and the vertical asymptotes into the shape of the cosecant graph. And so all you need to know is that between each of my different asymptotes, I'm going to have either U-shaped sections or upside down U-shaped sections. So for example, one section might look like this. Similarly down here, all these upside down U-shaped sections. It's not perfect, but I think it's close enough to give you an idea about what this graph looks like. So we can just call that good and end this video here.